Hey, Andy Pohl here. Animals teach us a lot, and that got me thinking. Can they teach us physics? Go ahead, Emmy. You can do it. I think she'd rather show you. So how would you figure out the velocity of a bird flying across the screen? Kinematics is the branch of physics that describes the motion of objects. In order to describe an object so complicated as a bird, we need to pick a spot in its body that moves steadily forward. The junction between the wing and the body is perfect for this. So now that we've picked a spot to follow, we need to capture the location of that spot as the bird moves across the screen. The resulting diagram is called a ticker tape diagram or an oil drip diagram. No matter what its name, the diagram repeatedly captures the position of an object at instants in time. That way, we can go back and analyze what happened. We begin the analysis by measuring the location of each dot in the trail. The distance between the tick marks is determined by using the length of the bird, which is 30 centimeters, and since the bird spans 4 intervals on the scale, the distance between tick marks is 7.5 centimeters. It's even easier to set the time scale. The video camera is running at 300 frames per second, and the dots that have been dropped onto the screen are dropped every 5 frames. So 5 frames divided by 300 frames per second is 1/60th of a second between each of the dropped dots. The most important step is to take these points that were constructed in the real world and map them onto the position time graph, which is a construct of our mind. It's conventional to show the time axis horizontal, so we simply rotate the graph in order to achieve this. To get the velocity, we need to consider what happens in the interval between 2 position measurements. The bird moves a certain distance and a certain amount of time elapses. It's the ratio of these two that gives us the velocity.